Good afternoon, my name is Misael Del Rio. I am currently pursuing a master's degree in material science and engineering at the Universidad Autónoma de Zacatecas. The poster that I'm going to present today is called Formation of Beta and Delta Phases during the solidification of aluminum and silicon alloys. As a first step, I will talk about the introduction part where a small context will be given about the topic that is being investigated. During the solidification of aluminum casting alloys, iron, manganese, and silicon contents modify the formation temperatures of aluminum intermetallic compounds, as well as their morphological and crystallographical characteristics. These compounds have diametral effects on mechanical properties, so knowing their formation mechanisms will provide alternatives to improve and optimize the control of formation and growth on desired intermetallics. The present research focuses on determining the range of chemical composition for the formation of beta and delta intermetallic compounds within the aluminum, iron, manganese, silicon system through the use of different characterization techniques. All this with the aim of providing information on the solidification sequence of iron intermetallic compounds in alloy of the aluminum, iron, manganese, silicon quaternary system. In particular, the effect of the chemical composition of the alloy on the formation temperatures and the morphological and crystallographic characteristics of the formed iron intermetallic compounds will be studied. The objective of the research is to determine the range of chemical composition within the aluminum, iron, manganese, silicon quaternary system for the formation of beta and delta intermetallic compounds. Now, I will show the experimental part of the research, for which 4 aluminum samples were prepared with a variation in iron content. These alloys were prepared from the aluminum ingots. The alloying elements added were iron, manganese, and silicon. Alloy 1 has an iron content of 2.5%. Alloy 2 has an iron content of 4%. Alloy 3 has an iron content of 5.3%. And finally, alloy 4, which has an iron content of 7%. After having prepared the 4 alloys, the solidification sequence in the formation temperatures of the intermetallic phases are determined through the thermal analysis curves, for which an experimental device similar to the one used by Baccarat was implemented. The forming temperatures indicate the temperature at which the isothermal treatment will be carried out. Table 2 shows the temperature for the isothermal treatment, for which the first alloy has a forming temperature of the 573 degrees Celsius. The other alloys have a forming temperature of the 574 degrees Celsius. The isothermal treatment lasted 18 hours, which allowed the formation and growth of intermetallic compounds. Finally, the intermetallic are extracted by dissolving the aluminum matrix in aqueous solution containing 20% hydrochloric acid as shown in the figure 2. Once intermetallic compounds were extracted, we proceed to characterize them by means of X-ray diffraction. Figure 3 shows the diffractograms of the 4 alloys obtained, in which the presence of the beta intermetallic compounds can be observed at angle 17. This in the 4 alloys. As for delta intermetallic compounds, it can only be appreciated very slightly in the diffractograms corresponding to the alloys with iron contents of 2.5% and 5.3% between angles 18 and 19. Contrary to the alloys with 4% of iron and 7% of iron, in which it's not possible to appreciate this compound. After the above, it can be concluded that in the 4 alloys obtained, the formation of beta intermetallic compounds at angle 17 can be clearly observed. As for delta phase, it can only be seen in two alloys. It should be noted that the results shown are preliminary and give away to continue advancing with the research. Since is it intended to perform a new X-ray diffraction in addition to the other characterization techniques such as scanning electron microscopy and transmission electron microscopy, in the order to visualize correctly the presence of both compounds and conclude our research work. Thank you very much for your attention. In case of doubts and comments, it will be available to answer. Thank you.